In this lesson we're going to look at collinearity again. We've already seen this in the straight line topic, but we're going to use a different technique here in vectors to prove 3 points are collinear. Collinear points lie all in the same line, like this here. These 3 points would all be collinear, so that you could draw a straight line that goes through them all, like that. If I put 1 point there, these 3 points are no longer collinear. So how do I prove that these 3 points are collinear without having to draw a coordinate diagram and sketch it all out, which would take a lot of time? Well, the first thing I would do is I would rearrange the coordinates from left to right. So that the x-coordinates were going from smallest to highest. And then I would think about what that meant. So if you take chunks here, for example, if you're calling this C, B and A, for example, these are the wrong coordinates, but just imagine this is C, this is B, and this is A. And what I'm trying to do is I'm trying to get the vector from C to B, and then B to A, two different vectors there. This one first, and then this one. Now, if we want to arrange this exactly, it may be a wee bit better. Let's do that. So what have we got? 0, 3, then we've got 2, 4, and then we've got 8, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that would be the vectors there, or the points, sorry. So we'll do the first bit, C to B. So again, using the position vectors, that's just B minus C, which is that there in column vector format. Take away that there. So 2 take away 0 is 2, and 4 take away 3 is 1. And then BA is A take away B, which is this here, take away this here. So 8 take away 2 is 6, and 7 take away 4 is 3. Now the way to prove that the points are collinear in vectors without actually drawing the diagram is to show that one vector is a multiple of the other vector, i.e. has a scalar multiplier in the front. We already learned in the previous lesson that vectors that are multiples of other vectors are always parallel. So that proves that these two vectors would be parallel. We also have to show from the same ideas in Unit 1 that they have a common point. If we can prove they've got a common point and they're both parallel, then we can do it. So if you can take out a common factor here, and in this case it would be 3, then what we're saying is that this vector from B to A is 3 times that of C to B, which means it's parallel. And also they both share the point B, which is this bit here, so they've got a common point. So a restatement to finish this off: since BA is equal to 3 lots of CB, which we just proved there, then those two are parallel. We can see that's CB actually. And also B is a common point, so A, B and C are collinear, or C, B and A, whichever way you want to look at it. C, B and A. So it's a 3-mark question, 1 mark, 2 marks and 3 for the statement.